Okay, fine. So today we are going to finish off, well, we're going to finish off this little last tiny little bit with trigonometry, angles, bits and pieces. And then we're going to move on to the next topic, or the last topic within term 1, which is logarithms and exponentials. Okay. So let's have a think. How would you measure an angle? What are the units that you use to measure an angle? In fact, before I ask that question, what is an angle? How do you define an angle? Good. So it's when two lines meet, for example, like this and like this, okay? And there's two angles there. Would you be happy? There is an angle in here. What type of angle would that be? It would be a acute one, because why is it got to be acute? Yeah, because it's less than 90 degrees, okay? Would you be happy there's also another angle in here? There's that one all the way around there. What would we call that one? It's not obtuse. It begins with an R. Sorry? Yeah, it's reflex, okay? So the reason why it's not obtuse has to be between 90 and 180 degrees, okay? Because it's greater than 180 degrees, it's got to be reflex, okay? I think Spandau Ballet sang a song about reflex, but anyway. So you've got reflex angles and you've got an acute angle. But it still doesn't answer the question, how would you define an angle? What do we reckon? So I would vote that an angle is a measure of turn. So if I'm facing this direction and then I turn to face this direction, would you be happy that I've moved through some angle? Okay, so I start over here and I move through some angle. Okay, so an angle is a measure of turn. Okay, it's an amount of turn. Okay? And clearly in this case you can either move that way, so clockwise, in which case it's going to be an acute, or you can move that way, anti-clockwise, in which case it's going to be reflex. Now, how do you measure angles? What unit do you use to measure angles?
Degrees.
Okay, so degrees is the most popular one. So talk to me about degrees. What is a degree? What is a degree? How many degrees are there in a full turn?
In a what?
In a full turn, how many degrees are there? Okay. So it's 360. What's the symbol for a degree?
A small circle of the top.
Small circle. Okay, in a full turn. Good. Now my question is why? Why is there 360 degrees in a full turn? So what this literally means at the moment is that if I treat that as a full turn, okay, treat that as a full turn, I start here, I turn all the way around to face back where I started, okay? What I'm literally saying is that if I divide that into 360 individual parts, okay, each one of those individual turns is worth 1 degree. So in a full turn, there's 360 of those little turns, all right? But my question is why? Why is there 360? Anybody, any ideas? Megan, what do you reckon? Why are there 360 degrees in a full turn? Anybody ever thought about it before? Well, to be honest with you, it's kind of arbitrary. Okay, so arbitrary means it doesn't really matter. Somebody just decided that 360 made a good number. Okay, in fact, there are two very particular reasons. The first reason is to do with factors. Okay, so what is a factor? What is a factor? If I said factors of 6, what would you say?
3, 2, 1.
And 6, yeah? So what is a factor then?
It's the numbers that can be divided, that they can be divided by.
Yeah, good. So you take a number and it's saying, right, what integers go into this number? In other words, what numbers can this number be divided by? So for example, if I take 6, 6 can be divided evenly amongst 1, 2, 3, and 6. So these are the 4 factors of 6. Okay. So let's think about 360 then. Okay. Let's think about 360. Is 1 a factor of 360?
Yes.
Yes. Is 2 a factor?
Yes.
Is 3 a factor? Is 4? 5? 6? 7? No. 8? 9? 10?
Yes.
So look at that. Out of the first 10 numbers, 1 through to 10, every single one of them is a factor, apart from 7. Yeah, that's pretty good going. And in fact, 360 is a pretty good choice because it has loads of factors. Now my question is, why is that important? Why is it important that when you're dealing with measures of turn, why is it important that your unit has lots of factors? Does anybody think?
So it won't be hard with decimal, like a decimal.
Yeah, good. So usually we don't want to deal with a full turn, we want to deal with like half a turn, or a third of a turn, or a quarter of a turn. Well, if you're dealing with each of those smaller turns, because 360 has loads and loads of factors, it means that they're going to come out as nice round numbers. For example, a quarter of a turn is equal to how many degrees?
90.
Yeah, 90 degrees. Okay. What about a third of a turn?
120.
Yeah, 120. What about an eighth of a turn?
45.
That's right.
Good. You could have just treated it as half of a quarter, which in which case is going to be 45. Yeah, good. Okay, but you're happy that because it has loads and loads of factors, it means that when you deal with like a tenth of a turn or a quarter of a turn or a third of a turn, all of these numbers, so the units, are going to come out as nice round numbers. Does that make sense? So it's important that our unit of measurement has loads and loads of factors. But there is also another reason. And the other reason is to do with sailors, of all things. Okay? So think back maybe 400 or 500 years ago, before we had mobile phones, GPSs, compasses. How did sailors navigate the globe? How do they always manage to know which direction they were heading in?
The sun.
Stars.
Yeah, the stars and the astronomy, okay? So if you go out tonight, okay, I mean, it's almost dark. Yeah, it's almost dark. If you go out tonight and you look at the night sky, imagine it's a clear night sky, okay, you will see a sort of a set of constellations. Let's say you look out in that direction, you will see stars which are in very particular constellations, okay? Now, if you go out in a week's time, look at exactly the same portion of the night sky, my question is, would you see exactly the same constellations of stars in exactly the same positions?
Maybe.
Not really. I mean, it's moved a little bit, right? If you go out in 6 months' time, look at exactly the same direction, exactly the same sort of portion of sky, you'll see completely different constellations. The reason being is because the Earth is rotating around the sun, okay? So you're looking at different portions of the night sky depending on your positioning in relation to the sun, okay? My question is, how many days approximately does it take for the Earth to do one full cycle? In other words, you go out, you look at the night sky,
365.
and you see exactly the same portion. It is 365, or it's about, because of course this is sailors, like we didn't know how many days there were in a year.
25.
Sorry? Yeah, it's 365 point and a quarter technically. Yeah, you're dead right. But it's about 360 days. Like if you were just looking at it from the night sky perspective, you go out 360 days time, you will see exactly the same portion of the night sky. Does that make sense? Okay. So sailors realised that it took about that many days for the Earth to complete a full turn. Okay. So they thought, well, this is embedded in nature. This is nice. Okay. So the reason why there's 360 degrees in a full turn, 2 reasons. Number one, lots of factors, means that a quarter of a turn, an eighth of a turn, a tenth of a turn, a ninth of a turn, they're all nice numbers. But also it takes about 360 days for the Earth to complete a full cycle. Now here's my question. There's no maths in here really. I mean, factors, it's not really maths, okay? There's no mathematical properties in there. Again, sailors, just because it's to do with nature, there's not really any mathematical properties. Like, if you're dealing with a full turn, you're usually dealing with circles, okay? Wouldn't it be nice to come up with a unit of measurement that actually embedded some properties of a circle within it, okay? So what I'm trying to say is, degrees, you've dealt with them all your life, that's great, that's fine, but I think we can do better, okay? So this is where our new unit of measurement, which we need to be aware of, comes in. Okay. So our new unit of measurement says, well, okay, let's scrap all that idea about salers and factors and things like that. Let's look at properties of a circle. Can you give me some properties of a circle? So can you give me some features which you can see in this circle? So what could I label on here?
Perimeter.
The perimeter? What's a better word for perimeter with circles? Circumference. Yeah, good. Okay. So that would be circumference. Good. Any other properties that I could label?
Radius.
Yeah. So radius. What's a radius again? Just remind me.
Distance from
Yep.
from the center of the circle to any point belongs to the circle.
Exactly. So it's the distance, the shortest distance from the centre of the circle to a point on the circumference, and it's always constant. Yeah, regardless of which point you look at, it's always going to be the same. But that's the definition of a circle. Okay. So in fact, could we use these two things to come up with a new unit of measurement? The answer is yes, we can. Okay. So here's what I want you to think about. Let me draw a bigger version of this circle. Okay, and let me draw my radius in. So my radius will go from there to there. I'm just going to call it R. Okay. My question is, if I was going to say that's the distance, so the distance from the centre of the circle to the circumference, and imagine that I started here. I started here on the circumference of the circle. What I'm going to do is I am going to walk around the edge of the circle until I've covered the same distance as that radius. Okay, so I'm going to use that distance there, and I'm going to take a walk around the edge of the circle, which is exactly the same as that radius. Okay, so in other words, I end up about there. So that distance from there to there is the same as one radius. Okay, now can you see that I have swept through some angle? In other words, there's some turn which has happened here. Like I was facing that way, I've then turned round, so now I'm facing this way. Can you see that? That is my new unit of measurement. Okay, that is what I'm going to call, well, it's to do with radii. Yeah, I'm dealing with radiuses, so I'm going to call that 1 radian. 1 radian. Okay, because it's to do with radius. So this is my new unit of measurement. It's a radian. Okay, so a radian is a unit of measurement that says if I walk around the edge of the circle, which is equal to the same length as that radius, that is 1 radian. Okay, so here's my question. How much will a full turn around the circle now be worth in terms of this new unit, this radian unit?
We can't know for sure until we have some numbers.
Can't know for sure. So what I'm trying to say is, if 1 radian is defined the distance that I walk round the edge of the circle, like 1 radius worth, how many radians would I sweep through to get the full turn of the circle? In other words, how many times does the radius fit in around the edge of the circle? Sorry? 4?
No, 2.
2? So you're basically saying, take that one again. I think that'll only get us to there if we do 2.
It's 2 pi,
It's 2 pi. Would you be happy? How do you know that?
because circumference equals to 2 pi r.
Good. Which literally means that the length of the circumference, the length from here all the way around to there again, is the same as taking the radius and doing it about 6 times. Yeah, 2 pi is 2 times 3.1415, so it's like about 6 times. Okay. So what I'm basically saying is that one full turn is equal to 2 pi radians. 2 pi radians.
So pi is equal to 180.
Okay, yeah, so what I'm trying to say is that full turn is 2 pi radians, which is 360 degrees. So what I'm saying is 360 degrees is 2 pi radians, okay? Well, I don't like this 2 in front of the pi. Let's imagine I'm just going to deal with 1 pi. How many would that be worth? Half a turn or 180 degrees. And actually, this is the reason why I use this symbol for radians, okay? It's half a turn. So remember, my degree is a full turn, 360 degrees, full turn. Because 1 pi unit of my turn is equal to half a turn, 180, then I use half a circle in there, okay? Now actually there's 2 different units that I could use. I could either use radians, or that half a circle, or I could use degrees, which is a full turn as well, okay? So here's my question. By the way, if you put pi as your unit of measurement, so you've got 2 pi there and pi there, you don't have to put any units because it's implied. Okay, so if you have pi as your unit of angles, then you don't have to put any symbol there at all. Okay, that's automatically implied it's radians. Okay. Okay, so in which case then, my question would be, use this, could you work out what 1 degree would be worth? So if 180 degrees is pi radians, how much would 1 degree be worth?
Pi over 180.
Can you see that? I've just divided both sides by 180. So 1 degree is pi by 180 radians. Okay. What if I wanted 1 radian? Okay. What if I wanted 1 radian? What would that be equal to?
180 over pi.
Can you see that? I've just divided both sides by pi. Yep. Degrees. So in other words, to get from radians into degrees, well, if 1 radian is worth 180 over pi degrees, then 2 radians would just be 2 lots of that. And 3 radians would just be 3 lots of that. And 10 radians would just be 10 lots of that. So in other words, I should take my unit of radians, multiply by 180 over pi, and I get my degrees. Okay, so to get from radians to degrees, okay, I would have to multiply by that. What if I wanted to go back the other way? What if I wanted to go from degrees to radians? What would I have to multiply by?
That one.
Yeah, good. Is that okay? Okay. So in which case, there's 1, 2, 3, 4, 5 things, conversions to have a go at the board over there. Could you have a go at those for me?